Hey guys, we're going to talk about transforming functions 6.4 today. We have been transforming functions since day one. We did linear, we did quadratic, we did exponential, we did logarithmic. I don't remember. Now we're going to do piecewise functions. And the way that you transform piecewise function is to do each piece separately. Okay? So I have on here just the standard rules. And let's look at a couple of these. Oh, I do want to point out, this stuff is very important. I would write this down. It says horizontal translations will change both the rules and the intervals of piecewise functions, whereas vertical translations affect only the rules. Okay, so this horizontal translation they're talking about, just left or right, that's going to affect the rule and the interval. Okay. So let's look at this one here. We're given this piecewise function, f of x, and it says to write the rule of g of x, which is a vertical stretch by a factor of 3. Well, you know, if you stretch something vertically by 3, you're going to multiply to the front of it. So my new function is going to be 3 times, I'll just write it up here, 3 times negative 1/2. So I have negative 3 over 2 x. And then my interval, my domain, it does not change because this is a stretch. This has not a translation. So I'll still write if x is less than 0. This one, same thing, multiply by 3. So now I have 3 over 2 x squared if x is greater than or equal to 0. So that would be my answer. The next one, they give us f of x, and we need to write g of x, which is a horizontal stretch by a factor of 2. So again, this is a stretch, so we do not have to worry about the domain or the intervals. So I'm going to go ahead and start writing. So if it's a horizontal stretch by a factor of 2, remember that it looks like a fraction inside the parentheses just on the x. So what that's going to look like, and I'll just jot it down right here, is you're going to have 1/2 times x and then the squared. When I simplify that a little bit, it looks like x over 2 squared, and I can simplify it even more by distributing that 2 to both the numerator and the denominator. So I have x squared over 4. So that's what my new rule looks like, x squared over 4. And my domain stays the same. So with the x minus 3, a horizontal stretch by a factor of 2 just on the x. So it looks like this. And then you can drop the parentheses. I'm going to write it with like x over 2 minus 3. And that's if x is greater than 0. I do apologize for this being so super messy all the time. It's the best I can do, I think. This one here, we're going to deal with a horizontal translation. Now this is the only one, the only type that you have to worry about the domain. Okay? If it was a vertical translation, no worries, still don't care about it. Only if it's a horizontal translation. Okay, so that part in there is important. So remember, if we go 4 right, that means that we are just going to put a minus 4 on the x. So I'm just going to write it over here. Just on the x, minus 4, like that. Okay. We can then simplify it a little bit because we can drop the parentheses. There's nothing else we need to do on that. So I will write x minus 1. Whoops, I hate when it does this. And it's my fault, I know that. I just don't know what button I'm pressing when I do that. Okay, so it's x minus 1. And we'll worry about the domain in a second. Let's do this one. We, again, just on the x, have to put a minus 4 because it's moving to the right 4. This time I can't drop the parentheses till I've distributed. So 2x minus 8 and then plus 3. So I can write that as 2x minus 5. Now let's look at the domain. And this is where it gets confusing. So we know that we put a minus 4 on there when we're moving right. And that seems wonky. Well, we are moving right. So what we're going to have to do is actually put a plus 4 on the domain. So instead of x is greater than 0, it's going to be x is greater than 4. And x is less than or equal to 4. So that's pretty much how you do these. I'm going to move on to the effects of transformations on intercepts. These rules right here, these notes are key. I still have to use these to be able to do these. So I don't have this memorized. I don't expect you to. But it can be memorized. You totally can do it. So it says when functions are transformed, the intercepts may or may not change. By identifying the transformations, you can determine the intercepts, which can help you graph a transform function. So I'm going to scroll down a bit. It says identify the x and y intercepts of f of x, so this function here, and then without graphing, identify the x and y intercepts of the g of x, so after we've performed this transformation. So in this case, this would be a horizontal stretch by 2. But let's first start with f of x, and we will write f of x's x-intercepts and y-intercept. Okay. So the y-intercept's the easy one, right? That's just down 4, so y-intercept's negative 4. The x-intercept, to find that, you have to put 0 in for y. So over here, I'll do it up here, my scratch word. So 0 equals negative 2x minus 4. I'm going to add 4 to both sides, and then I'm going to divide by negative 2. So my x-intercept is going to be negative 2. Now that I have that figured out, I'm going to decide what my g of x intercepts are going to be. So to figure that out, I have to decide what the transformation is. The transformation is a horizontal stretch by 2. So I'm going to go up to my rules, and it says right here, if you have a horizontal stretch or compression, your x-intercepts are multiplied by that factor, but your y-intercepts stay the same. So my x-intercepts are going to be multiplied by that factor of 2. So I get negative 4. And my y will stay the same, so negative 4. So these are my answers. I'll just circle them. No, I won't. I'm a terrible circler. Ta-da! And now I'm going to have to erase part of my circle so I can do the next problem. Okay. There. So let's look at this one. We have f of x. We want to find the x and y intercept of that. Y is the easy one. Remember, that's just negative 1. This is just a quadratic function moved down 1. My x, you have to put a 0 in for y to find your x-intercepts. So when I solve this, I add 1 to both sides and take the square root of it. So the square root of 1 is plus or minus 1. It is quadratic, so it is totally fine to have 2 x-intercepts. Then we'll go ahead and we will look at the next function. g of x, and it's telling us that this negative x here, that's reflect across the y-axis. Okay. So we need to look and see what we have to do to reflect across the y. That's right here. To reflect across the y, your x-intercepts are negated and your y stays the same. Okay, so my y stays the same. I'm going to just rewrite that. And my x-intercepts are negated. So instead of a positive 1, I'll have a negative 1. And instead of a negative 1, I'll have a positive 1. So in this case, it's really just the same thing. Okay. Let's look at 2/3 x plus 4. We will find our x and our y-intercepts for that. My y-intercept is a positive 4. My x, I need to set it equal to 0 and solve. So I subtract 4. And then I will multiply by 3/2 on both sides. So I have negative 6. And then I'll do my g of x and y intercepts. And what's happening here is it's reflecting across the x. So let's look and see if we reflect stuff across the x. My x-intercepts will stay the same and my y's will be negated. So I still have a negative 6 for my x-intercept and my y-intercept becomes negative 4. This last problem on here, I put a little caution sign because this looks like a problem from your assignment, I think. I want to say it's number 18 or something like that. 14, number 14, okay? So, but it's different. I use this part. This part's the same. So you'll have the same x and y intercepts as what I come up with for f of x, but this part's different, okay? So don't just copy this down and think that that's the answer. So just wanted to make you aware of that. Okay, so my f of x, I need to find my x and y intercepts. My y-intercept is negative 4. And to find my x-intercept, I have to factor this into groupies. Okay? So it looks like to multiply to negative 4 but add to negative 3 is going to be a minus 4 and a plus 1. Which means I have to set each of those equal to 0. So what I have for my x-intercepts is a positive 4 and a negative 1. Now let's take a look at our g of x. What's happening is 2 steps, okay? So I'm going to actually do this in 2 steps so that you can see. This will actually be my final answer, this one here. So we have a reflection across the x, and we have a vertical stretch by 2. Okay. So we'll just take those one at a time. I'm going to go left to right, so start with the reflect across the x-axis. So to reflect across the x-axis, my x-intercepts will stay the same, but my y's will be negated. Okay, so my x's will stay the same, 4 and negative 1, and my y will be negated. Okay, so that's the reflection I did. And now this one, I'm going to take this stuff and vertically stretch by 2. So to vertically stretch by 2, your x-intercepts will stay the same, but your y will be multiplied by that factor. So again, my x-intercepts are going to stay the same, 4 and negative 1, and my y-intercept has to be multiplied by 2, so I have 8. This would be my answer for my, wow, that's great, my g of x, and this is my intercepts for my f of x. Okay, let me know as you have questions. This assignment isn't due, 6.4 is not due till Friday, so hope you have a good week.